Hello everyone, welcome back to PN&L channel where we create content with practical IT solutions. If our videos are helpful to you, kindly subscribe to this channel. Click on the thumbs up button and let us know in the comment section what you would like to see. In this video, we will be installing and configuring self-signed certificates to secure OpenStack services communication, install Rabbitmq services, which we will talk about shortly. So the first thing we're going to do is to ensure that we have configured the host names and IP addresses in the /etc/host file on each of the controllers. So let's double check that. It's configured. So next, we're going to enable non-local binding kernel parameter on all controller nodes. This is going to allow us to be able to use virtual IP address that is connected to the HA proxy. We're going to we are going to add this configuration on all the controller nodes. We need to ensure that Linux kernel supports network bridge filters by verifying all the following CTL values to ensure that they are set to 1. So in order to do that, we're going to run the following commands. So first we're going to check we're going to run lsmod grep filter, net filter. So we're going to check that. Okay. So since there is no values that has been returned, so it shows that the BR net filter module is not installed. So we're going to run the mode probe net filter. I'm going to run that on all the services. So because we don't have it installed, so what we're going to do is we're going to run this command. So as you can see, we're going to run it both for IPv4 and IPv6 because we're going to be allowing OpenStack to run IPv6 as well. So that has been completed. So the next thing we're going to do is we're going to configure certificates on all the controller nodes. So the first thing we're going to do is to configure this openssl.cnf file. If you watched my previous video on how to install HA proxy, you will see how we configured these certificates on there. And we're going to do the same thing on all the controller nodes. We're going to comment this out and add the new directory where all the certificates are going to be located. We're going to ensure that that is the comment section there is correct. So same thing here. I believe this process can be scripted. However, I have not explored that yet, but it's something that I will consider in the future. Hopefully these videos are very informative and I get encouraged to create more videos like this. can script it, or we can use Puppet or Ansible to automate these tasks. So the next thing we're going to do is we're going to create new certs directory and the CRL, which is the certificates revocation list. I'm going to do that on all the controller nodes. So what we're going to do is we're going to go into the HA proxy node and copy the interindex.txt file and the serial. We're going to copy all this file into to all the controller nodes. We're going to do the same thing for cd/etc ssl. Sorry, I'm supposed to have changed directory there. We do the same thing for on the second controller node. And then on the third controller node. Okay, so the next thing we're going to do is we're going to move all those files into their respective directories. So we use that. We're also going to copy the .rand file from here as well. Okay, that has been copied. Then we're going to move those files on each of the controllers or the controller nodes, and then change ownership. So next we're going to copy the CAR. We're going to copy that from there. Okay. Next, we're going to copy the private key to all the nodes. No, sorry, we're copying both the private key, OpenStack private key, and the certificates. Right. We've copied all the certificates that we need. So we're now going to move those certificates to their respective folders on all the controller nodes. And then we're going to change ownership to root. Okay. So the next thing, we're going to install Certify. So but first we're going to install Python 3-pip on all the nodes. We wait until each and every one of the files are completed. So all done successfully. So now we're going to install Certify. Okay. So next, what we're going to do is we're going to type in Python 3, and then we're going to verify where the CA certificates.crt files are installed. So we're going to type in Python 3, import certify, and then we're going to verify the location. That's where we're going to copy the sorry about that. So this is where the CA-certificates.crt is located. So we can do the same for all the rest of the nodes, but it's going to be the same. So what we're going to do is we're going to press Ctrl D to exit. So now what we're going to do is we're going to add the CA file to the CA-certificates.crt. We're going to do that on our controller nodes. So we're going to cd into the certs directory, as you can see here, /etc /certs/ca-certificates.crt. Then we don't want to exit. Okay. What we can do is we can cd out of the certs, because if we exit, we're going to be exiting out of there. So we have concluded the installation of the certificates. The next is we're going to configure Crony, so that we have a synchronization of the timing. So what we're going to do is we're going to install Crony on all the nodes. So next thing is we're going to comment out the existing or the default pool, and then we will now add the time server that matches our time zone. Mine is time.nrc.ca. I'm going to do that on all the hosts. Then we will restart Crony. So that's the end of Crony installation. The next thing we're going to do, or the last thing for this video that we're going to do, is we're going to install Rabbitmq. Now, Rabbitmq is a message queuing service that facilitates inter-process communication in OpenStack. This is done using the message queuing service in the backend. Rabbitmq is an advanced message queuing protocol framework which provides message queues for peer-to-peer communication. We will be enabling transport level cryptography for this queue using TLS for the messaging client connection, provides protection of the communications from being tampered or eavesdropped when the messages are in transit to the messaging server. So that's what Rabbitmq does, and we need to secure the communication using TLS. That's why we configured the certificates. So we're going to be using the certificates to encrypt the communication between the services. So now we're going to install Rabbitmq on Rabbitmq and Memcache. Memcache, as the name denotes, is a memory caching. Because of the messaging, sometimes the messages are being cached for efficiency. So we're going to install ERLang. ERLang is the language that Rabbitmq is written in. So we're going to install Rabbitmq server and memcached, and also Python 3 memcached and Apache as well, because most of these services uses Apache. So we're going to reinstall all this on all the controller nodes. So we're going to wait until the installation is complete, and then we will be able to continue. Okay, that is completed. So the next thing is we're going to add some configuration to the rabbitmq.conf file. So as you can see here, Rabbitmq is going to be using the CA cert file, which is the ca.cer that we created, and also the OpenStack PEM file and the OpenStack key that we created earlier on. We're going to add all this configuration into the rabbitmq.conf file. We're going to add that on all the controller nodes. So the next thing is we're going to ensure that the directories are readable. Use the SSL-private. If we don't do this, we will not be able to access the files. So on individual controllers, we're going to add the node name and also the ports on each of the controllers. So we're going to start with controller 00 node. and then we proceed to the next controller. So as you can see here, this is the port that is going to be Rabbitmq is going to be communicating on, and the IP address of this node. Press enter. Next, we're going to restart the Rabbitmq server on controller node 1. And then we're going to check the status. Okay, so the cluster node is Rabbit at this here. And as you can see, everything is looking good. So what we're going to do next is we're going to copy the cookie hash on this server here to all the rest of the servers. So we're going to do that. And send that to controller 1. So we're going to do the same for controller 2. Okay. So we copy that to controller 2 and 3. So the next thing, we're going to move this file to the /var lib rabbitmq on controller 2, which is this one here. Okay, so here we did not add the fully sorry about that. We did not add the trailing slash there. Okay, that is done. So we now move to controller, the second controller node, and configure the rabbitmq-env file. Then we restart the Rabbitmq server. So the next thing we're going to do is we're going to add the going to move this also in on, we're going to do the same configuration on the third controller node. So since all nodes of the cluster are authenticated in the previous configuration that we ran, we can now run the command to join the each controller node to the cluster. because right now, as we saw earlier on, when we ran that command here, status, we can only see that the running nodes, there's only one Rabbitmq node that is running, which is os-alt-conf00. When we run the same command again, we will see that all the other nodes have joined the cluster. So what we're going to do is we're going to stop the app running the Rabbitmq here, and then we're going to stop it. So it has been stopped. So now we're going to join this node to the cluster by running this command, as you can see here. So as you can see, it has joined the cluster. So then we will now start the app on this. So the app has been started. So the next thing what we're going to do next is we're going to configure the third node. The same process we went through for the other ones. We're going to add this to the rabbitmq-m file, or -m.conf file. So we're going to restart the Rabbitmq service on there. Once that is done, we will now so we'll now join this to the cluster. So we're going to stop the app. And then we join it to the cluster. Okay. Then we start the app back up again. Okay, so now we have joined all the nodes to the cluster. So the next thing we're going to do is we're going to add a user to the cluster, so we can actually access this via the web. So we will add this user. We only run this on the first controller node. So as you can see, Rabbitmq-ctl add_user OpenStack. You can use any user and any password. So the next thing is we're going to grant the OpenStack user permission to be able to access the Rabbitmq services. Then we will now set a Rabbitmq policy to for high availability policy. So this is it. We allow this. And that's done. So the next thing we're going to do is we're going to check the status. And when we check the status here, we will see all the nodes that are in the cluster. So as you can see, Rabbitmq node 1, node 2, and node 3 status not under maintenance, so which is good. There are no network partitions. Everything is looking good so far. So the next thing is we're going to enable web management. We're going to run this on all the controller nodes. You can disable this management interface by running Rabbitmq-plugins. Rather than use enable, you can use disable. So that way it will disable the management interface. Okay. So now we're going to grant the OpenStack user as the administrator on the web interface. So now what we can do is, if we go to the web interface, we can use this HTTPS. So rather than use 8080, we're going to use 5671. Accept risk. My bad. So the web interface is actually 15671, not 5671. 5671 is actually what Rabbitmq uses to communicate with the rest of the services. So we're supposed to be using 15671, and we're going to use the password we created earlier on. So as you can see, this is what the interfaces look like, and you will see the connections, the channels, the exchanges, the queues. As you can see, there are no queues because we have not enabled any queues from the OpenStack services. So if we also go to the HA proxy, if we click on refresh here, as you can see, the Rabbitmq management is showing that we have communication between the HA proxy and the Rabbitmq management. So the next thing we're going to configure is we're going to configure memcache. So the first thing we're going to do is to comment out the default loopback IP address on each of the servers. And then what we're going to do is we're going to add the IP addresses of each of the nodes into memcached.com file. So next, we're going to restart the memcached, Rabbitmq, and Apache. So we're going to restart those services. So as you can see, because we are restarting the services on there, it's going to refresh, and it's going to change from the statistics not being available. Now, once the service restart is complete, you can see here that all the nodes are configured correctly. Thank you for watching. That will be end of be the end of this video. In the next video, we will be installing and configuring Keystone, which is the identity service management on OpenStack. Thank you very much for watching. We'll see you in the next video. Thank you. Bye-bye.